Hello guys, and welcome to the new video on Microbit Pomodoro project. Some of you maybe noticed there is something wrong with this Pomodoro timer, and it has to do with counting the time of 25 minutes and 5 minutes. If you already discovered it by yourself, congratulations on that, and let's go over to see what's happening. So we are making a pause of 1 second, and then we are doing some additional processing, like calling the display LEDs, additional checks, and so on. And this will in total be more than 1 second because additional processing takes some time. But first, let's see if that time is significant. So I will start the Pomodoro timer and we'll see how much it takes to finish up. And we are done. As you can see, the difference is quite substantial. So it's well over 25 minutes. And let's see now how we can fix this issue. Let's visualize how Pomodoro timer is working once it is in running state. We have a part of the time spent on processing, meaning it is going to render the LEDs and evaluate some if conditions. Then we want to put our timer to a pause, that this processing time and the pause together should last for 1 second. Now it can happen that the next processing time will be different than the first one in length, and our pause interval then should be longer so that it will fit to 1 second. And this cycle repeats over and over again. After our processing time, at this point, and this one, and this one, we should calculate the pause time. How much should we pause? And let's mark this as A and pause time as B. A plus B must be 1000, and B is 1000 minus A. Our final goal is to calculate A, or processing time. You may wonder how we can do this. There is one block on Microbit board that is helpful for dealing with these kind of calculations, and it is running time block. And you can see in parentheses it says milliseconds. So this is, it says here, find how long it has been since the program started in milliseconds. At any point in time, if you call this block, you will get the exact amount of time from the moment that you powered on the Microbit board. I will show you two approaches to solving this processing time A. The first approach is to simply take, at this point in time, to take the running time from the Microbit board and to subtract the start processing time. And this is something that we will calculate while our Pomodoro timer is running after each pause period. So after the pause is complete, we need to remember this start processing time. So once we calculate A, we pause for 1000 minus A, and then we set the start processing time to whatever this block gives us back. And when we come back to this point again, we know that current running time minus start processing that we remembered is the processing time. And then we need to adjust the pause for the next one. Let's go over an example to show how it works. If our Pomodoro timer starts running at this time, so basically after 12 seconds, a little bit more over 12 seconds, we start on button A, then this is what we get for the running time. We don't have the start processing phase because we start from the pause itself, so we can just copy over the running time here. The difference is 0, and we pause for 1000 minus 0, which is 1 second. And after the pause time, we come to this point, for example. And this is going to be our start processing time. So it is 13,780. In the next iteration, what is happening is that I'm just copying this start processing to here. Running time is, for example, 13,880. Difference is 100, and the pause time should be 1000 minus 100, which is 900 milliseconds. After that pause expires, start processing is equal to 14,780, because we had 900 and if we add these 900 to this running time, this is what we get for this point here. If we go to iteration 3, let's say this is our new running time, the difference is 140. If we make a pause for 1000 minus 140, we get to start processing of this much, 15,780. If you pay attention, you can see that start processing was 13,780, then 14, then 15,780. It should be exactly 1 second apart. Let's now go to the second approach. This one is having less code, and we don't need additional variable like in the previous approach, so there is no need to keep track of start processing time. But it can be a bit tricky to understand at first. So I will show you how it works and what is the formula, and then we'll go over an example. So to calculate A, we simply take a remainder of running time divided by 1000. And this will be our processing time. And we just need to simply pause for 1000 minus A. Let's go over an example. We'll take the same one as in the previous approach, so 12,780. A is 780. If you take a close look, you will see that it is actually the last 3 digits, and it makes sense, because what is the remainder of something divided by 1000? It is whatever are the last 3 digits. We need to pause for 1000 minus A, this is 220, and this is important thing. After pause, we will land on the full second, because what we are doing actually is we are making a pause up to 1 full second. And in the next iteration, it will be clear how it works. So running time at this point here is 13,100. We know that after this pause, the last pause, we had 13,000 of running time. So this 100 will be our processing time. And it's simply the remainder of dividing by 1000, because we know that after pause, we didn't have any remainder after division by 1000. Now we need to pause for the same 1000 minus A, and after this pause, we get 14,000. Let's go over one more iteration, but it's all the same. And now I hope that you see that this is actually much simpler than previous approach, because we are going to take whatever is left after division by 1000, and we pause to make it up to 1000, and you see how it will nicely follow each second. So it will go 13,000, 14,000, 15,000. And this is the approach that we are going to implement for our microbit Pomodoro timer. Let's go ahead now and implement our new pause time. So we need running time in milliseconds. This is the one that's provided by microbit. Let's take from math operator remainder, and we want to have a remainder of running time over 1000 milliseconds, and we also want to take math operator to subtract the remainder from 1000. Let's put it here as our new pause. Let's move this a little bit. And now let's try to run this simulator once more and to see if this time it is behaving better. And we are done. This time you see that it took exactly 25 minutes, which is great. That was all for this video. I hope that you enjoyed this. Thank you for watching and see you in the next one. Bye bye.